Hi, I welcome you all for next lecture series. In this series, we are going to discuss about flip-flops. So, introduction of flip-flops is the fundamental of building blocks of digital electronics used for storing and transferring binary data. They are bistable circuits with two stable states representing binary 0 and 1. A flip-flop is a sequential logic circuit that has two stable states and is used to store one bit of data. If changes states based on clock signals and input conditions. So type of flip-flops are SR flip-flop, you can say it is a reset, JK flip-flop, and D flip-flop and T flip-flop. D means you can say it is a data delay, and T means it is a toggle. First, SR flip-flop. SR flip-flop is the simplest type with the two inputs S and R. S and R can say it is a set or reset. It stores a single bit of data. When S is equal to 0, R is equal to 0, the output, there is no change in the output. If S is equal to 1, R is equal to 0, the flip-flop will be set, and S is equal to 0 and R is equal to 1, the flip-flop will be reset. If both S and R is equal to 1, it is invalid state. So, what we have discussed in the clearly, it is shown in the truth table, that is 0, 0, there is no change. And there are, I can mention in the previous slide, it has two outputs. One is Q and Q bar. It is inverted outputs are there. That we can say it is a complement. So Q and Q bar. So if Q is 0, then Q bar is 1. So both inputs are 1. It can be invalid, both Q and Q bar. So to overcome this problem, we can go for the JK flip-flop. Is improved of RS flip-flop, resolving the invalid state by toggling the output when both inputs are 1. So the same condition here also is mentioning is as in the SR. That is 0, 0, then no change. 1, 0 is set and 0, 1 is reset. So we can approach JK flip-flop to overcome the fourth input, that is both inputs are 1, 1, that we can say it is invalid or toggling. So in the stage, the output toggles used in the counters and the shift registers. So in JK flip-flop, we can say it is the toggle mode. That is Q or Q bar. Here it is Q or, and we can say it is the toggle mode. Then next flip-flop is D flip-flop. You can say it is the data or the delayed flip-flop. It can be used to store the data or the clock edges. So operation, we have two possibilities because 2 power n, n is mentioning the number of inputs. So we have one input, so possibilities of outputs, inputs are 1 or 0. So 0, we can say it is a rising edge, 1 is the rising edge, output will be 0, and 1 for output will be 1. So the operation of the D flip-flop is the output Q follows the D input and the triggering clock, and used to store the data and the synchronization. And next one is T flip-flop. So T flip-flop we are using, and we can say it is a toggle states with every clock pulses. It is derived from the JK flip-flops by tying both inputs together. So here also we are using a single input, so possibilities of inputs are 2, 0 or 1. So if input is 0, T is equal to 0, output is Q, and input is 1, output will be Q bar. It can be used in counters normally. So these are the diagram of our 4 flip-flops. One is T flip-flop, JK flip-flop, RS flip-flop, and then D flip-flops. So here we are using normally NAND gate to form the logic gates along with the See the SR flip-flop, all they are using four flip-flops. All the flip-flops are NAND gate, and there are two inputs, and along with this, the second input is clock pulses. So in T flip-flop, we are using J and K inputs are together and form a D. Likewise in the T also. So JK flip-flop having two inputs, one is J and K along with this clock inputs. And in JK flip-flop, output of Q bar is connected to the one end of input of J, and Q is connected to the other input of K. So based on this only, we are achieving the toggle mode. So the application of flip-flops, data storage, frequency counters, and the control circuits. In data storage, used in registers and memory elements, and frequency deviations, flip-flop T flip-flop divide clock frequency by 2, and counters JK and the T flip-flops are used in binary and decimal counters. Control circuit synchronizing data and state machines. So these are the application of flip-flops. So recap this session is we are discussing about flip-flops and type of flip-flops. Type of flip-flops are RS, JK, T and T. So we are discussed in this session deeply, and we are so if you all have any doubt, please ask me.